what are the coefficients? Let me just pull these out, right? I'm going to say ck plus 1 on ck. By the way, I'll just make a little note. Many textbooks, including the one that you mainly use, they don't actually use c for coefficient. They use little t. I find that somewhat maddening because then you've got capital T for term, and they choose little t, which it's the same letter. And why use little t when you've got a perfectly good letter? So I just want you to read out. If you see the questions and they keep on phrasing it in terms of little t, this is what they really mean. Because the coefficients are the important part. We're not interested in the greatest term. You can't find out which one the greatest term is because x is variable. Okay, so we're always looking at the coefficient. I just want to evaluate it first, and then I'll launch into the inequality. Okay, so let's have a go at this. Sorry, here's the one that's going to be on the numerator. Okay, so just step by step, let's pull out the numerical parts of it. Okay, we already mentioned there's going to be this guy. Then you've got this guy. I'm now going to simplify it the way that Reynard suggested. Okay, doesn't matter really. Then you've got this guy. Okay, so there's the coefficient of the k plus 1th term. Then on the denominator, I'm going to have this coefficient, the one I already highlighted in green. So it's going to look like this. Okay. Yes?
Should it just be 3 to the k plus 1?
Oh, of course it is. Yep, thank you. Pull out the whole term. Okay, now, when you have a look at this fraction, admittedly, it looks a bit intimidating because you've got so many things happening. But this is kind of like cancelling heaven, right? There are going to be so many things that disappear. For instance, there's the first thing we already identified, which is that this 1 to the whatever and this 1 to the whatever, they're just gone. I don't even need to think about those. In the same way, just as Brendan helpfully pointed out, you've got some number of 3's here, and then you've got also a number of 3's here, exactly one less, right? Exactly one less. So what will happen is you'll lose, different color. You'll lose all of these 3's, and what you'll get left with is just one of the 3's on the top. Does that make sense? Now, there's a final bit of simplification, and it's where the most work is, in that I have to go back to remember what on earth these things are, because there's going to be a lot of cancelling there too, right? So let's just recall, you might want to write it up the top here. NCR, generally speaking, right? Again, it's a fraction. What's on the top? N factorial on? Okay, fantastic. You may like to jot that down. It's on the reference sheet, but it's good enough to have that up there because it's not that hard to remember and you're going to be using it a lot, okay? So, because what I've got here is going to be fractions on fractions, I'm going to sort of break them apart so I don't confuse myself with my own writing, okay? So first, let's do 5c k plus 1, okay? That's going to be 5 factorial on k plus 1 factorial. And this is going to be, what's this? Think about it carefully.
4 factorial.
Isn't it 4 minus k?
It's going to be 4 minus k.
This number here is the same as this number, isn't it? Do you see it's the same as that number? If you can't quite see it. The n here is the 5, and then you're subtracting k plus 1, right? So that 1 will bring it down to 4. So you're getting this. Do you agree with that? Okay. Now, rather than write this again over a big fraction line, I'm going to say divided by this guy, right? So this is 5 factorial on k factorial 5 minus k factorial. So I've dealt with this, I've divided by this. All of these guys disappeared, and then you multiplied by 3. That's the 3 that's left over. How does it look so far? Making sense? Okay, good. Now, have a look. Before I do my flip fractions upside down, all that kind of thing, some of this is really easy to work with. For instance, this 5 factorial on the numerator and this other 5 factorial that's on the numerator, you divide through, and they cancel. So these are gone. That's nice. Okay. Yes? Like if I did 3 divided by 3, they would cancel. Okay. And you're left with these guys. Okay, look, k plus 1 factorial divided by k factorial. Well, k plus 1 factorial is k plus 1 times k minus 1, k minus 2, all the way down. I include all of these terms, except there's an extra k plus 1. Right? Does that make sense? So just be careful in the way that you write this. I'm going to write it on the next line like this. Here. Okay, I've got, remember this fraction, it turns upside down, right? So I'm going to write that on the numerator now. And then to help us make sure we cancel this properly, I'm going to write you might recall back in term 1 last year, we called this unrolling the factorial. So it's got this extra term out the front, k plus 1, and then the rest of it is k factorial. K minus 1, k minus 2, etc. Okay? So there is that guy, and then lastly I've got this 4 minus k factorial. All multiplied by 3.
Doesn't
Yeah, I'm just not finished yet, that's all.
Okay, right.
Okay, the reason why I'm breaking apart, you could see, what I did here, I can do here as well, and I will. But students so frequently muck up this, like they get the two things confused with each other, that I'm going to just do them as 2 separate lines. You don't spend that much extra time. So now, I can cancel this and this. By the way, you'll notice as much as I possibly can, I'm trying to circle things here rather than crossing them out, because as a marker, I still want to be able to read what you're doing and know, oh, you've cancelled something, you recognize what it is. A very common error that people make is when they're doing this cancelling, they skip this line. And so they cancel k factorial, and then they cancel the exclamation mark just there, and then they misread their own working, and it's a bit of a disaster, okay? It seems like a silly thing to do, because isn't it obvious? But in the middle of an exam when you're rushing, it's not obvious, okay? So I think it's worth writing this extra line so that you can write out exactly what you're going to cancel. Last thing I'm going to do here, I'll put that 3 on the numerator back where it belongs. This guy, I'm going to do the same unrolling thing, right? So this is 5 minus k times 4 minus k times 3 minus k all the way down. So I'm going to write the 5 minus k out the front, the 4 minus k factorial, which is going to cancel in a second. And this is my ratio, okay? So last one. These guys will cancel. And a last. Okay, so this is the ratio, right? That, generally speaking, is what will generate these numbers down here for me, okay? And now that you can see I pointed that out, I'm now going to get rid of it, because what do I want to do with that ratio? I want to solve for when it's greater than 1, right? Which will tell me where, in what region, what part of the binomial coefficients in the expansion will it continue to get bigger and bigger. Can you go ahead and solve that for me while I rub this off? Find out when that thing is greater than 1.